Okay, I need to start off by saying I've been trying to figure out a way for this screen recording to work for like 2 hours now. And everything I've done, I've had some kind of problem with. So I am praying. A friend told me that this would work. I am praying that it works. If it doesn't, I'm gonna be very, very upset. But this also goes to show that no matter how hard something is for you, you just gotta keep going. Because if I get this figured out, you can do chemistry. It's just fact. Okay. So I want to go through each of the concepts that you're going to need to know for your quiz on Friday and beyond, because again, as I've been saying, this stuff builds. So I'm going to start with the first topic that we got into was basically just seeing where electrons are located within the atom. So remember, the first thing that you have to do here is you have to find your element on the periodic table. This is sodium. Okay. Sodium is atomic number 11, which means that sodium has 11 protons, right? To find the number of neutrons, you are going to take the mass number that is given, which in this case is 24, and you are going to do 24 minus the number of protons. So 24 minus 11, which is 13. And then the big thing that we've been talking about with this unit is electrons. So the number of electrons is going to be equal to the number of protons because we are assuming it is a neutral atom. So the positive protons and negative electrons need to cancel out. So now we got to fill in our electrons. And remember, the electrons want to be as close to the nucleus as possible, just like we want to be front row at the Backstreet Boys concert. So I need to fill in 11 electrons. I'm going to start in the center. 1 on top, 2 on the bottom. That energy level is now filled up. So I have to move out to the second energy level. So I'm going to go put the third one on top in the second energy level. And remember, they don't want to be near each other if they don't have to be. So the fourth one is going to go on the right. The fifth one is going to go on the bottom. The sixth one is going to go on the left. At that point, they will start pairing up. So number 7 is going to go on top. Number 8 is going to go on the right. Number 9 on the bottom. Number 10 on the left. That is filled up, but we still have one more electron that we need to put in there. So number 11 is going to go in the third energy level on the top. The next thing it asks for is the group number. So sodium, again, is number 11 on the periodic table. I look to the top. It is in group 1A. And then it wants to know the number of electrons in the outer energy level. Now, by this time, we know that the group number should be equal to the number of electrons in the outer level, but we should double check to make sure that we filled in the correct number of electrons. So I look at the last level that has anything in it, and it has 1 electron in there, which is what I was hoping for. So I'm going to say that there is 1 electron in the outer level. And remember that those outer electrons are called valence electrons. The last thing that we did with this type of problem was the Lewis dot diagram. And to do that, you put the symbol of the element, and then you put the number of dots equal to the number of outer electrons or valence electrons, which again, because this is in group 1A, it has 1 valence electron, which means it's going to have 1 dot. We fill in our dots the same way that we would fill in our electrons. So if there were more, let's say we had an atom like oxygen, which is going to have 6 valence electrons. When we fill those in, we go on the top, then the right, then the bottom, then the left, and then we start pairing them up, top, right. So just keep that in mind. So that was the first thing that we did. We then talked about the idea of the octet rule. And again, that prefix octo means 8. So the octet rule is basically saying that atoms want to have 8 valence electrons. Now remember, there are some atoms that already have 8 valence electrons. And those are the noble gases. They're in group 8A. They already have 8 valence electrons. They're stable. They're happy. They're not really going to be part of this bonding thing because they already have what every other atom wants. So the goal for all of the other atoms then is to somehow get 8 valence electrons. So that leads us into the next section where we talked about how is an atom going to get 8 valence electrons. And from what we've talked about so far, it can either get 8 valence electrons by gaining more electrons or by losing more electrons. Just a reminder to you, you cannot gain or lose more than 3 electrons. And by you, I mean atoms. So sodium, for example, currently has 1 electron in its outer shell. To fill up that shell, it would need to gain 7 more in order to have 8, but you can't gain or lose more than 3. So instead of gaining 7 more, sodium would just lose the 1 that it has, and now it has a different outer level. The outer level is now the one beneath that, and it has 8, which would make sodium happy. So remember that by losing a valence electron, it would go down to the level beneath it, which is typically going to be full. So going back to our chart here, we have magnesium. So I find magnesium on the periodic table, and the first thing it wants to know is how many valence electrons does it have. So to find that, I'm going to look at the group. It's in group 2A, which means that it has 2 valence electrons. To draw its Lewis dot diagram, again, I'm going to draw its symbol, and it's going to have 2 dots. So I'm going to start one on the top, one on the right. Again, we cannot gain or lose more than 3 electrons. So it currently has 2. To fill up that shell, it would need to gain 6. That's more than 3. We can't do that. So the other option then, what's going to happen is that it's going to lose the 2 that it has. Now keep in mind, here's where people get a little confused. The thing that you are losing is electrons. Electrons are negative. So if an atom loses negative electrons, it is going to take on a positive charge. So magnesium's charge would be +2. For the next one, the next example that it gives us, it is nitrogen. I'm going to find nitrogen on the periodic table. Nitrogen is in group 5A, right? Group 5A, which means it has 5 valence electrons. So to draw the Lewis dot diagram, I write the symbol, and I'm going to do 5 dots. 1 on top, 1 on the right, 1 on the bottom, 1 on the left. That's 4. So 1 more on top, 5. Again, can't gain or lose more than 3. So nitrogen can't lose 5, not possible. But it can gain 3. It currently has 5. If it gained 3 more, it would have 8, and it would be happy. So it's going to gain 3, and remember again, it is gaining negative charge. It's gaining electrons, which means its charge will be -3. So when you gain electrons, you become negative. When you lose electrons, you become positive. The next section, or the next question, I should say, number 7, wants to know basically what are atoms that can't form ionic compounds together. So remember, we talked about the fact that this staircase separates the metals from the nonmetals. And for an ionic compound to work, you have to have one of each. In other words, you have to have an element on the left of the staircase and an element on the right of the staircase. So if I had niobium and fluorine, that would work because I have one on both sides of the staircase. If I had sodium and selenium, that would work because I have one on both sides of the staircase. On the other hand, if I had nitrogen and sulfur, that would not work because they're both on the right side of the staircase. Same idea if I had osmium and strontium. That would not work because they're both on the left side of the staircase. So to have an ionic compound, you have to have an element on both sides of the staircase. So that was number 7. That's what that was asking about. So it wants you to give an example of something that would not work in terms of forming an ionic compound. So then the next part was where we show the ionic compound actually forming. So we had talked about the fact that atoms are going to gain or lose electrons. Well, how? Where are they going to go? So that's what this section is about. Now keep in mind, this section has 4 separate parts that you need to do. So I will do number 9, which is barium and phosphorus, because honestly, this is the biggest one, the most difficult or longest one that you're going to see. So to do these problems, you are going to find the element on the periodic table, and you're going to find out how many valence electrons it has. So barium's number 56. I look, it's in group 2A, which means it's going to have 2 valence electrons, or 2 dots. So I'm going to draw BA, and I'm going to give it 2 dots. And then I'm going to find phosphorus. Phosphorus is in group 5A, so it has 5 dots. So I'm going to draw P for phosphorus, and 1, 2, 3, 4, 5 dots. So now we have to show the transfer of electrons. Barium wants to lose its electrons, 2 of them, and phosphorus wants to gain 3. So what's going to happen is barium's going to give 1, 2 electrons to phosphorus. And remember to show where the electron's going with your arrow. So barium is now happy because it got rid of both of its extra electrons. The problem is phosphorus originally had 5. It only got 2 more. So it only has 7 now. It wants 8, which means it needs another electron. So the way that it's going to get another electron is from bringing in another barium. So barium's then going to give 1 of its electrons to the phosphorus. And now that barium has an extra electron. Phosphorus already has 8. Barium still has one it needs to give away. Well, who's it going to give it to? It's going to give it to another phosphorus. So again, phosphorus has 5 valence electrons. Let me draw that a little better. 5 valence electrons. So what's going to happen here is barium is going to give one of its electrons to phosphorus. Okay, phosphorus now has 6. Barium has gotten rid of both its electrons. It doesn't have any more to give to phosphorus, but phosphorus wants 8. It needs more. And so I'm going to bring in another barium. So barium will give 1 to phosphorus. Phosphorus now has 7. 2 to phosphorus. Phosphorus now has 8. So everybody now is happy. So that was step 1. And by the way, I keep track by kind of putting check marks. Okay, I did that step. Step 2, we're going to do our brackets. And in our brackets, we need to say how many of each atom there is and what their charge is. So there's 1, 2, 3 bariums. So I'm going to write Ba3. Then I need the charge of each individual barium. Well, each barium lost 2 electrons, so each barium has a charge of +2. Now I look at the phosphorus. There's 1, 2 phosphorus. So I'm going to put P2. Each phosphorus gained 3 electrons, so each phosphorus is going to have a charge of -3. So now I'm done the second part. Check it off. Now it needs the formula. Now when we are doing it this way, we do not crisscross. We just say how many of each atom we have. So we have 3 bariums, so we're going to say Ba3, and we have 2 phosphorus, so we're going to say P2. Ba3, P2. Then the last part, so we've done that. The last part, which I think is the easiest, is the naming. So remember with the first element, you're just going to find it and you're going to write its name, which we already know is barium. So we're going to write barium. With the second element, you have to take off its ending and change it to IDE. So the second element is phosphorus. So instead of phosphorus, we're going to change that to phosphide. And now you've completed the whole problem. Check that off. It is done. Make sure that you have all of those parts. So that's the long way, and we'll get in a second, we'll get to the shortcut on that. The next section, again, I feel like is the easiest section. You just have to name the compounds. So you find your element. We have for number 12, KBr. So I'm going to find K. K is potassium. For the first element, just write its name. The second element is Br. So I'm going to find Br on my periodic table. Br is bromine, but again, remember we have to take off the ending and change it to IDE. So instead of bromine, it becomes bromide, potassium bromide. And that's it. Then for the last section, this is where we do the crisscross rule. And the reason we do the crisscross rule is that when we're finding the formula, it takes a long time to have to write out all of these arrows and dots. So the crisscross rule is basically a shortcut. To use the crisscross rule, you need to make sure, first of all, that you have all those charges written on the periodic table. If you don't have the charges, you're not going to be able to do the crisscross rule. But the way that the crisscross rule works is you find the element on the periodic table. So number 19 is rubidium oxide. So I'm going to find rubidium. Rubidium's number 37. I'm going to go to the top. I see that its charge is +1. I'm going to write Rb +1. Then it says oxide, rubidium oxide. Remember, oxide has actually been changed. The element that I'm looking for is oxygen. So I find oxygen, number 8. It has a charge of -2. So I'm going to write O, -2. Then I'm going to crisscross. And what I mean by that is as follows. When I want to know how many rubidiums there are, I'm going to look at the charge associated with oxygen, the number associated, which is 2. And then I'm going to crisscross it. That's how many rubidiums I'm going to have, is 2. When I want to know how many oxygens there are, I'm going to look at the number associated with rubidium, which is 1. So remember, we don't actually write the 1. You can if you want to, but technically if no number is written there, we know it means 1. So this is rubidium oxide. A couple of things that I have noticed people doing. Some people are putting charges, pluses and minuses, in the formula. Charges do not go in the formula. Also, some people are writing their formulas like this, where the subscript is kind of up on top. Subscript needs to be on the bottom. There is one exception to the crisscross rule, and that is like number 20. Number 20 is calcium sulfide. So I find calcium Calcium is on periodic table number 20. I look up, it has a charge of +2. So I'm going to write Ca +2. Then sulfide, calcium sulfide. Remember, sulfide is actually sulfur. So I'm going to find sulfur on the periodic table. It's number 16. I look, its charge is -2. So sulfur is S -2. When the charges are the same, calcium's +2 and sulfur's -2, they're both the same, just opposite charges. The numbers cancel out and you just end up with one of each. So it would be just CAS. So that is it. If you are still having any issues, obviously reach out, but hopefully that helped and hopefully this recording worked. Please, please, please. We will see.